69 miles.
Okay, so
58 point something.
Let's get back to saying about the orbit. Let's just switch to that. So
the orbit of what?
Earth were to be flat, then as we see in real life, the sun go under
the orbit of what? What is orbiting? What are you observing that is orbiting?
I'm observing that it's orbiting the sun, and that's also because we have gravity and we have its gravitational pull.
You're saying that the Earth is in motion?
Yes.
You will have to provide evidence for that the Earth is in motion.
Okay, I cannot provide evidence. I don't know.
Exactly. And that will be a nonsensical argument because you're actually observing the sun moving across the sky and the luminaries. Remember earlier about what makes sense and what doesn't? You don't have motion of the ground. You cannot detect it. You cannot detect it with equipment. You cannot feel it yourself with your vestibular system that indicates axial rotation if it was spinning. And you're observing the luminaries moving across the sky, and you inverting that and saying the lack of detection of movement is because there is movement. You see, it's completely non-logical.
Well,
logically,
so if I were theoretically outside of the Earth and zero gravity, assuming that's real, then I would be able to easily then tell how Earth has motion, but I can't feel it.
You see, you're jumping the bridge before you have the materials to build the bridge, and before reaching the bridge, before even having plans of the bridge, you're saying that you already made it past the bridge. So you're saying that if you go outside of reality and you skip the lack of motion that you can detect here on the ground, if you skip that, and you skip the non-curvature, right? That it's not in there. If you skip going outside of the contained environment that we're in, you skip that and you go outside of reality. From there, from that place, you can see the Earth as a globe.
Wait, so you don't think the Earth's spinning?
Can you provide evidence that it is?
Well, the sun. You see,
the sun, okay. Let's follow this logically. Earlier you said logic. You observe when before the morning comes at the sunrise. What are you observing? The sun rises from the east and it moves across the sky.
Rises from underneath the horizon, and if it rises from underneath, then how is some parts of the Earth having sun if there's no underneath of the Earth because it's flat?
Okay, that is claim stacking on top of each other. Remember, you don't have the Earth is not moving. The actual observation is that the sun is moving, and you inverting that into saying that phenomena that you're observing is because of the Earth moving, even though you don't have that.
The sun doesn't rotate around the Earth. I don't know what point you're trying to make here. Yeah, okay. The sun.
Have you ever heard of sunrise and sunsets? The sun or noon. Have you ever heard of noon? What is noon?
When the sun is exactly above.
Okay, and what happens? Okay, so the sun comes from the east, from the horizon, and then when it's directly above your head, that's noon, right? So it moves position across the sky from one place to another place. Now noon, and then afternoon, and then sunset, the evening. And you're saying that's not happening. You're saying that no, that's not happening.
What? That doesn't make any sense. The Earth is rotating around the sun.
That doesn't make any sense. Listen of what you're saying. You're saying that your sensory. You're saying it doesn't make sense. You observe with your vision, your eyes, one of your senses, that the sun is moving across the sky. You're saying that doesn't make any sense. And you're saying the Earth is in motion, even though you have your vestibular system that detects motion, detects rotation, and you don't sense it. And you're saying your senses make no sense, and the nonsense makes sense.
Because I observe the sun moving. If the sun were to stay above the
sun is moving. There you go. The sun is moving. You made it.
And the Earth is. And you don't want to believe. Is that correct?
Ball
You
Earth.
don't think the Earth's moving. You think the Earth's completely still.
You don't have any actual evidence of that.
Yes, I do. Yes,
It's
I do.
Ball,
I'm
hold
gonna
on,
tell you.
guys. Ball Earth Jesus, known as Einstein, his entire theory that allows for the universe, known as relativity, actually hinges on the point that there is no difference between the Earth standing still and the universe rotating around it, or the universe rotating around a stationary Earth. Or like the Earth spinning within a stationary universe, right? So your idea is moot. Like that whole thing, that whole argument can be explained both ways if you believe in Einstein, which you clearly
but my
do because you
argument
believe in a
is
ball Earth.
sensical logic, and his argument is nonsensical logic. And Einstein is saying that both things can be true at the same time, which is a contradiction.
Because it just doesn't make sense. If the sun is much, much, much larger than the Earth, and the Earth is
That's
flat,
if, bro.
the Earth
Again,
I can't prove
bro.
I've been to space.
You're being
I haven't been to
cool, bro.
space.
I
You haven't
respect
been to
you.
space
Listen,
either, so you
brother.
can't
I
prove
respect you. I respect you. You sound cool.
either.
Everything is okay. But now you're stacking fallacies on top of each other. Now
You
you're
can't prove it.
saying if the sun is this other thing that I don't observe it to be, therefore your conclusion is this and this and that. Complete nonsense.
No, it just makes sense. Okay.
No, it's contrary to what you sense. It's
Hold on,
contrary to what makes sense.
Let's do it from your point of view. Okay, I wake up, the Earth is flat. Okay, if the sun is much larger than the Earth, and it moves, and the Earth doesn't move at all, so it moves around the continents, right? Then it would be bright all the time across
No, you've got it.
The
You've got
sun
it
is
wrong.
not larger than the Earth, bro.
Let me
That
say
just
something.
makes sense.
10 seconds. 10 seconds. You've got the size of the sun. You got it wrong. When you're looking at the flat Earth, the Earth is bigger than the sun and the
Way
moon.
bigger.
Are you insane?
Yeah.
Are you insane?
Yeah. Yeah. The Earth is
You know
bigger.
how perspective works?
You
Law of
believe the flat
perspectives.
Earth is bigger than the sun?
Hey, bro, remember the outside perspective that you say you weren't looking at? You're looking at the solar system from an outside perspective, the cartoon version of the actual observed phenomena. You're looking at a misrepresentation of what the sun is and replacing the actual observed phenomena by a cartoon that you were given.
Okay, so then this argument's pointless.
But it's nonsense. Like, that's my whole point. The argument that the sun is not moving, that the Earth is, and that the sun is bigger than the Earth, that's complete nonsense, non-logical.
I just realized, yeah, this argument's pointless. You've never been to space. You don't know. I've never been to space. I don't know. This argument's pointless. It could be real or it could be fake. All right,
We do know something. You know what we do know? What we do know is that the Earth is not curving and the sun is moving across the sky and the sun is not bigger than the Earth. We do know that.
We know from our perspective on the Earth, the only thing we know is that the sun is moving, and that's all we know. We don't know if the Earth's flat.
Claiming the opposite will be nonsensical.
We don't know. You haven't been to space, have you? You haven't seen
space is. Remember, the space. What you think of space is an impossibility. It cannot be.
You don't. What's an impossibility?
Okay, what you think about space is the cartoon of the global system that you were thinking about earlier, that the sun, you draw the sun like a big yellow circle, and then you draw the Earth and Venus as smaller circles. That imaginary thing, that's not reality. And what's surrounding that, the blackness or the whiteness or whatever you can color it with, that stuff is not the reality we live in.
Oh yeah, you been there?
You haven't been there. I haven't been there, and we know it's impossible.
This argument's pointless. I haven't been there.
No. You still haven't. We still haven't reached the conclusion, bro. It's not that it's pointless. There is an actual point to this. You know what is the point?
Conclusion until we go to space. Okay, let me ask you a question.
No, bro. You're jumping. It's okay, bro. Don't get triggered. It's okay. You're cool. It's all good. But bro, if the space place that you're calling space that is real, if that was the case, you wouldn't be able to breathe air.
The Earth produces its own oxygen.
And the gas pressure that you're breathing when you expand the volume of your lungs with your muscles, right? that you expand the available medium of your lungs and the gas pressure rushes towards your lungs, that gas pressure requires a container, because gas pressure is the force that the gases exert on the walls of its container.
Oh, jeez. Okay, well,
this is what it is, and it's not my fault or your fault. This is realist level stuff.
it's just okay. Let me just ask you a what if, because I know you hate.
Remember, just to bring the point home, the space thing that you think is next to the high pressure system of Earth, the gas pressure, it cannot be, because if that was the case, you wouldn't be able to breathe air. And you are breathing air. There is gas pressure. Therefore, that space claim that you believe that the Earth is a spinning water ball in the vacuum of space, that's impossible. Complete nonsense fantasy.
Well, I don't know, so I can't prove it, and you don't know.
Remember, we do know. No, you're underestimating yourself, because you do know the Earth is not curving. You haven't measured that. You haven't proved that to yourself. You do know that it is motionless. Your vestibular system is already telling you that, and you don't have any tests that will go contrary to the Earth being motionless. You do know that the sun is moving across the sky. Claiming the opposite will be nonsensical. You do know that you breathe in air. You do know that. There's a lot of things that you do know. But the nonsense claims of the globe, you're saying, no, I don't know any of that stuff. But because you don't know any of those nonsensical fantasy claims, that stuff doesn't supersede reality, bro.
Okay, so you only believe in your perspective. You don't believe in telescope photos. You don't believe in NASA. You don't believe in.
I've looked through telescopes, and I know that what I'm looking at is stuff. Yeah, it's observable phenomena.
Have you seen a Voyager take the picture of the Earth? That's fake, right?
Voyager? You're saying something that went outside of reality and is taking pictures from outside of reality.
Correct.
And listen, the Voyager, you're saying that it's showing you what the Earth is not curved. The Earth is not curving; it's contained, and the Voyager is showing you something that you cannot verify.
So you don't believe in the photos.
Well,
right?
Those photos are from something that is not in reality. Those are not photos. Remember, those are images. Images. It's different.
Really not, though.
Yeah, because when you take photos of reality, you can pull up the infrared, you can pull up high optical zoom cameras, you can pull up cameras that can see on the optics in the spectrum of light. And when you look across the surface of the Earth, it's not curving. So if the Voyager is showing you an image of a cartoon curving, that is not what you see in reality.
Oh, yeah?
Yeah. And the container, the contained environment that you're in requires a container, and the Voyager cannot break the container. Okay, if the Voyager can break the container, you wouldn't be able to breathe air. Because the gas will go to that available medium. That medium that you think the Voyager is in, showing you cartoons of the Earth, that medium doesn't exist.
Okay, I have a good question for you then.
No, okay. This question, hold it one more second. The Voyager is equivalent to, you're saying, I have Aslan. I have this girl that went to Narnia and spoke to Aslan and took picture with Aslan and spoke to the witch and proved me wrong, or Godzilla. That's what you're saying the Voyager is. Now, go ahead with your question.
Okay, I have a question. Let's say, and this is another hypothetical, and I know you hate these, but it's a possibility, because you could do this one day. Let's say, get in a rocket ship, you go to outer space, and you see the Earth's round. Are you going to be upset?
The outer space thing, the outer space. Okay, rockets. We can devise rockets. We can devise rockets that can go up and then down, right? We launch them. They go up and then down. They're not going to the fantasy place Narnia that you think they're going. They're not going there.
Oh, do you not believe you can leave Earth?
Okay.
Do you think there's like a boundary or something?
That will be a belief. That will be a belief without evidence. that you can leave these contained environments.
If I have money one day, I will pay you to go on a rocket ship into space.
You know the billionaires, the richest people in the world have tried and they cannot do it.
Oh, you want to? So yeah, you believe there's a boundary. You believe you can't leave.
Bro, there's gas pressure. You are breathing air. Gas pressure is the force that the gases exert on the walls of its container.
I mean, you wear oxygen tanks when you leave, but that just makes sense.
Listen, that makes sense. That the gas pressure is the force that the gases exert on the walls of its container. That makes a lot of sense. That's the only way you can demonstrate it, and that's what we observe. That's gas behavior. It does make sense. What you're claiming about the gas not flowing towards the low pressure of uncontained outer space, that doesn't make sense.
Right.
Listen, let me read something from you real quick, because hopefully you can bring this point home and realize.
Oh, there's nothing to realize because I can't prove it. Neither can you. So. Okay.
Well, we can prove that the gas pressure is caused by the gases pushing against the container.
And hey, maybe I take a rocket ship, I go to space, I explode and die, and then someone will realize.
You know, what will you get in a rocket? Nobody's gonna do that.
No, maybe if there's a boundary, or if there's some type of thing where you can't get to space, like you're saying, I get in a rocket ship and I can't.
Listen, okay, let's say you get in a rocket and you go very high up, and then you come back down as a hero, whatever. You're not gonna show the Earth as a curving sphere in the vacuum of space. That's not what you're gonna see or show.
How do you know that? You've been there?
Because you cannot go high enough to see the whole of the Earth, and you cannot go to this fantasy place you think is outer space. You can't go there.
Do you think outer space is a fantasy place?
Remember the globe that you don't have, the curvature, the curving thing that the Earth is not doing. The Earth is not curving. And then next to that, there is this vacuum, this emptiness place that you claiming is next to the high pressure air that you're breathing on the Earth. That is not possible. You cannot have a high pressure system next to a low pressure system without a container.
I think it is.
Oh, you think it is? You believe it is?
Do you believe in the ISS, the International Space Station, or is that a myth?
So look, well,
not real?
we can have high altitude devices up there, sure, but it's not in this place that you call outer space. It's not there. It's not next to a spinning water ball, because the Earth is not curving. It's not rotating. So all of these ideas that you show about outer space is not what you think it is.
Oh, okay, because you've been up there, right?
No, but you haven't been up there.
I know. I can't prove it. It's non-proven.
And people can go, let's say people can go very high up, but they're going to stay within the contained environment that we're in. They're not going to go beyond that point and show you this fantasy place that you think you can show. You can't do that.
Okay, well, maybe, once again, like I said earlier, I'll pay for you when you're older, or when I'm older, for you to go on a rocket. Unless you're, scared to or whatever, but I'll pay for you to go on a rocket, and then...
Look at this, buddy. Pressure is caused by gas molecules hitting the walls of the container. With a smaller volume, gas molecules will hit the walls more frequently, and so the pressure increases. You see?
Right.
So
why doesn't he pay for himself to go to space first and foremost? Then he would know. Then hang on a minute. Then you would know, and then you could then offer Gemsy to go as a lift, as a offer after you've been yourself. That's what would normally be happening.
I'm really planning when I'm older to have enough money to be able to go to space. Will I probably
You're going to waste your money for something that cannot be done, dude. Come on.
Well, that's a bummer. Waste my money. I don't really care. I mean, we're all going to die on a rock or...
Listen, bro. The rapid motion and collision of molecules with the walls of the container, listen to this word. It's very important. Causes pressure. You hear that?
Cool. That's cool.
So now take a deep breath right now. Right now, take a deep breath.
Just
You see that to be able to have that gas pressure around you, for you to be able to breathe it, a container has to be in place.
Oh yeah, the atmosphere and gravity holding it in. That's the container. Yeah.
The atmos is the air. That's the gas pressure. The atmos. The sphere will be the sphere will be a contradiction. Okay, atmosphere is a contradiction of terms because gases have no inherent shape. They take the shape of the container. They don't have an inherent shape. So you're saying atmosphere is one
they're
thing.
omnidirectional.
Yeah, they go all directions, and when you expand the volume of your lungs, and you can take a deep breath. If there wasn't a container in place, like you're saying, outer space, whatever fantasy, the gases will be going towards that available medium violently, and they will be leaving your lungs violently. You get that?
No.
You don't get reality. You don't get the loss of thermodynamics. You do get that. Come on.
No. I've never been to space. Neither have you, so we can't prove this argument.
No, so we've never been to Narnia. We're never gonna go to Narnia, bro.
We can prove entropy. We can prove entropy here on Earth by having a vacuum chamber, and you evacuate the air and then pump it in and see what happens. That can be demonstrated even up to 10 to the minus 3 to 4 tall here on Earth. We can.
Okay, what if you prove that and then you take a rocket ship and then you see the Earth spherical? What are you going to do?
No, we can't. That's the problem. We can't go to space because rockets themselves don't work in a vacuum.
Now I'm going to say it. That will be you running away from your claim. You're claiming that the thing that you're standing on is curving, and now you're gonna run away from it. And you're saying, "I'm gonna go to Fantasyland and not measure what I'm claiming is curving, and just make assertions about Fantasyland." You're running away from your claim, bro. Why are you doing that?
Fantasyland and see the Earth's a sphere, and then I'll know if it's a sphere.
No. You measure the thing you're standing on. You measure the Earth. You're saying the Earth is curving. If you can provide measurements of it curving, then you have something.
Nobody can ever measure the entire Earth. You'll run into mountains.
Yeah, you can look. If they hang on a second, hang on, Jamesy. Let me just ask him one question. Listen, young man, if you are given the specifications to something, a gentleman's suit, a pair of shoes, the dimensions, you can check it to know that it's the right size. Yeah, you can check that. So if they've given you the numbers of the Earth itself, we should be able to check it, shouldn't we? If they've given us the numbers, should we not be able to verify that? Yes or no?
I don't know.
Oh, again.
I haven't
one time. If you're given the numbers to the size of the Earth, shouldn't we not be able to verify it? If they've measured it, that means we should be able to measure it. Yes?
Possibly, if we have the right tools.
Yes, right. Okay, that's good enough. Right. So you need to go and measure the curvature of the Earth. Then you would know. You don't need to go to space. They didn't go to space to give us those numbers. They gave us those numbers here on Earth. Do you understand?
Okay. Sure.
Right. Yeah, you can see good thing. He's being honest. He's conceding to that point that you cannot measure the curvature of the Earth, and that's not for the globe argument. If there was a curvature, you will be able to measure it, but the fact that it's not measured because it's not a globe.
Do you know how long that will take, buddy? Do you know? Do you know how long it would take to measure California to Las Vegas?
You can measure 20 miles, and there's laser tests. There is long distance observations. You can measure a section across a body of water, and within that section, you can determine if there is any drop over distance. And then you can add that section to another section, and a bunch of people have done this together already, and come to find out, we have flatness all over the surface of the Earth, no measurements of curvature.
You did that? You measured the entire Earth? You did that?
You know about California. You mentioned California, right? Let's see. What is it? Indiana. You know, the is one of the Indiana or Idaho, and then Florida. many of the states in the United States are described as flatter than a pancake. You know that, right?
Have you measured the entire Earth? You measured it?
No, I haven't done that, and you don't have to do that to determine if there is curvature across the surface.
Wait. So we're on the same page. You haven't measured it. You don't know. I haven't measured it. I don't know. So we don't know. Huh,
we have measured sections of it.
Right.
Yeah.
Though, and we haven't measured the whole thing.
Listen, across Florida, there is no curvature across Florida. That's a big section of the Earth. You know that, right?
Across Florida, that is not that big of a section of the Earth.
Isn't it?
It's really not.
Okay, so what about maybe five states of the United States? Is that like a decent section of the U.S.?
I wouldn't say so.
No? Okay.
I would say if we measure across the entirety of America with a perfectly flat ruler and it starts bending, then we'd know. If it stays perfectly flat the whole time, then we're okay. The Earth's flat.
No, Mick? Is that Mick?
Yeah, quick. Yes, sir.
Go ahead, Mick. I think you're cutting out a little bit. Go ahead.
Oh, sorry. Hi, Cloud, can you hear me?
Yeah.
Dude, from what it sounds like, okay, do you have any reference to anyone who has done some sort of measurement in the past to determine the values that we have?
No.
No, okay. So why is it that you take it at face value?
What do you mean?
They tell us that we live on a ball of 3,959 miles, right? But there's no measurement. So why do you think we live on a ball of 3,959 miles?
Because that's what I've learned in school, and that's what I want to think. Why do you think it's flat? We could live on
Okay. So they didn't give you any measurements. They didn't give you any proof.
They didn't give you any measurements that it's flat either.
They didn't. Hang on. They didn't give you any of that. You're in here demanding for these same measurements, going to the contrary. But what's your means? What is your method by which you determine which is true?
I just wanted to hear opinions. I just wanted to know.
So you're in the wrong. I think you're in the wrong room then, because this is not about opinions. This is about measuring shit. Take a ruler, you put it up. I guess a piece of paper. Inches. That's not an opinion.
So this room. Right? Wait. So this should be completely.
Berserker, your hot mic.
Berserker, hot mic.
Yo, what the? So this room should have 0 people because nobody in this room has measured the entire Earth. Yes or yes?
But no, that's not even relevant. Why is that? Why?
Yeah. Why is it relevant?
Why is that your qualifier? Why is that your qualifier? Gemsy already pointed out to you. Okay, there's a method by which if you do it in sections, right, you can come to certain conclusions. Right?
But you
think of this. Think of this, dude. If you think of this, right? If you take a little basketball, okay, and you put a ruler on top of it, within the first inch or two, okay, from the ruler to the side of the ruler on top of the basketball, you will notice nonlinear distance increase between the surface of the basketball and the ruler. Right? You don't have to measure the entire thing to determine the rate at which that basketball is dropping away from the ruler.
But if you did, you would know your answer.
You would have a lot more clarity, a lot more certainty for sure. But even by that method, you can still calculate to a certain degree of precision. Now, with that line of thinking, you would assume that they would have had done this, right? An entire Earth curve measurement. An Earth surface measurement, or even a type of measurement like this, where they're doing a section. Right now, in the entire time that I've heard you speak to Gemsy, which is not long, I only recently got up. You haven't brought anything to the table.
No, because I haven't measured the Earth.
Right, but do you know anyone who might have done it in the past?
No.
Okay. So, I mean, like, you're kind of, you got nothing. You're here criticizing or antagonizing, but you can't prove your position. So, I mean, case closed, dude.
But how can you prove it's flat? If you have not been listening,
you haven't been listening to Gemsy, right? He's been giving you methods, or at least I thought I heard at least one. Right? If one can show no deviation from one point to another point, or at the very least, not the deviation that would be expected on the ball of said dimensions, you would concur that there might be something wrong with the provided measurement, right? They say we should have exponential growth or nonlinear growth from point A to point B along the surface. We go out, we measure that point A to point B, and we get no deviation whatsoever.
When are you going here?
They won't make any claims, man, because you have to back them up. So this is I'm asking you questions.
Rob, you're a robot.
Yeah,
dude.
you're roboting.
I think we're leaving soon. Okay. 10 minutes.
Go ahead.
Oy.
Who are you guys talking to?
Clownify.
Yeah, I'm here.
Clownify. Is there anything you learn? Are you American? If you don't mind me asking.
Yeah.
Is there anything they taught you in school that you questioned?
I've questioned a couple things, but I don't have a true answer, so there's really no point.
About manifest destiny. Do you think that's true?
No.
So
I
haven't
questioned the Earth is flat because I haven't measured the entire Earth. I haven't questioned.
No, I'm just saying other things that the government taught you. Did they teach you anything that you're like, that's bullshit?
Not really, because I don't really care that much about school.
What about Wounded Knee? Did they tell you what happened at Wounded Knee?
No. They don't teach, a lot of stuff. That's probably important.
Yeah, it's kind of just like babysitting at this point. They're just keeping kids off the streets.
Yep, basically. But either way, I don't really care that much because the Earth's flat, cool. The Earth's round, cool. We're still living. I'm still going to die in 70 years, and that's it. Like, it doesn't really matter. So
yeah, that's the point. That's the point we're making. In the globe Earth, they told you everything would change. It was a giant leap forward.
Who did?
The Apollo program. In the Apollo program, they told you everything was going to change. And it's been 60 years. What the fuck is the holdup?
I don't know. I mean,
well, the Earth is
work
flat.
For them or something.
That's it. The Earth is flat. That's why nothing's going to change around here. It doesn't matter how many giant leap forwards you think you're taking. They'll all be face plants.
Nothing's changed, so we assume it's flat.
No, nothing.
Is that what you're saying?
Nothing changed, so you assume their claim.
What did you
giant leap forward was bullcrap.
What did you want to change? What was supposed to change?
Well, they tell you. What did they tell you in school? What was going to change?
They didn't really specify much. The only reason we learned the Earth was a sphere is because of photos that obviously aren't true in your guys' beliefs. Radius, circumference, I guess some old measurements. But yeah, that's about it.
Photos will be the ones that you take. Photos will be the stuff that you take from the realist level. The stuff that you have about the globe, those are not photos. Those are images or stitches of things put together. Like
they're images. They're CGI. They're AI. They're programmed or whatever. They drew the Earth over the photo.
When you take a photo, when you take a photo of reality, you don't see any curvature in the photos.
Because the Earth's too big and we can't zoom that far. Thank you very much.
Earth's too big.
Yes, that is what I just said.
In the photos, you don't see the globe. In the cartoons, you do see the globe.
Correct. Because in the photos... So
you see the problem there?
Are you talking photos outside of Earth or inside of Earth? Or inside, or... Well, I mean, you guys don't really believe in an outside of Earth because
there is no photo outside of Earth.
Okay, you don't believe that?
No,
Okay,
it's not that
remember you.
it's not that I don't believe that. If you can provide it, I will believe it. Okay.
Like, are you wanting a photo of Earth from the outside, or like different things from Earth outside?
Are you saying that? Are you saying that image is photo or photo is image? Or photo is photo. When you take a photo, you take a photo, or you're constructing some digital thing in computer. What do you want? Photo or some digital things from computer?
I don't know, probably photo.
We don't have that photo. The only one photo where they're claiming that's Apollo, I think in 72. Only one real one they are claiming. There is no one photo of the Earth from outside.
I mean, I don't know. I've heard telescopes take photos.
Yeah.
Or images.
Yeah, telescope takes photos. Can you take a telescope and make photos of the Earth?
No, I don't have enough money to do that.
Can you have 10 miles of flatness on this
Can
sphere?
I count 10 miles?
No, can you have it?
Can you have 10 miles of flat surface on this Earth?
On this Earth, yeah.
Yeah. You can buy
No,
it.
you cannot. No, you cannot. You know why? Because on 10 miles, you're going to have 66 foot drop everywhere from your point. All around 360 degrees. Do you understand? You cannot have 10 miles of flat surface on this globe.
Yeah, you know that for a fact? You've done it?
Yeah, I done it. I done it. If you want to know, I done it in my life in Croatia, in the UK. But if you want to know, I done it like 3 weeks ago. It was in Edinburgh, and you can find it's called Beach Portobello. It's near in Edinburgh, and then you can in 24 kilometers you can reach for your height the lighthouse. If you want to know, yes, I did it 5 or 6 times in my life in different locations, different countries. Yeah.
It's just mind
And
boggling.
it's just my mind also. I don't know now to deny the reality or to believe people. What to do?
Well, you can't. Once again, like I've said 2 trillion times, you can argue all you want. You can throw up all the gases, all the science, all the measurements you want, but until we have a confirmed measurement around the entire Earth, which who knows how long that would take, until that happens, we won't know an answer. So you can't assume it's flat.
Can I ask a simple question? What is sea level?
What is sea level?
Yep.
Loki, I forgot. Should know this actually.
Is it level or flat?
Is it flat?
Is it level flat?
Is it level flat? Believe so. I don't know.
Okay. Is it sea level flat?
Probably. I don't know. Maybe. Yeah.
How much sea we have on the Earth?
I think
Sea surface.
75%.
If 75% of the surface is flat, is that not enough for measuring the Earth?
Do you know that? You measured it?
Let's go. Let's do it again. What is the sea?
You didn't measure it. You didn't measure it. Nope, you didn't measure it.
I measure it in every town. I go to the town in UK and I change the town, and every town saying this is elevation above the sea level. Do you know? But if you are on the sea and when you go to across the sea, you are not changing that elevation.
And you've measured it. You've measured 75% of the Earth.
I don't need to measure it. I know how liquids behave in nature.
You don't need to. Yeah,
okay,
right.
Okay. Can I ask a simple question? How liquids behave in nature when they are still?
How does liquid behave?
Yep.
When it's still?
Mm-hmm.
I don't know. It's still. Just sits there. I don't know.
The surface of the water.
Yeah, it's flat.
Mm-hmm.
Oh.
The reason.
And that means does not curve.
And you know the ocean has tides because of the moon, right? Or do you not believe that either?
Does tides curving?
And the reason the ocean's flat way out there is because we have a thing.
Is it tides the changing of level or changing the curve?
The ocean's flat and it won't change levels because of gravity.
Is it tide changing the level or changing the curve?
Changing the level.
Okay, that means we have
up
tides
and going
down.
going up
The
and
flat
going down.
surface. That means the flat surface is going up and down. Is that correct? Or curved surface going up and down?
The curved surface. It's not curving in and out. It's not. It's like not
Yeah,
curving.
it's not curving. We are saying that we are on the same page. Yes, the water is not curving. The sea is not curving. The oceans
I
are
didn't
not
say
curving.
that.
Yeah. We don't need to say that we know that because that's water. Water does not speak; it behaves, And then you look how water behave in
The
nature,
Earth's
and then you
too
say,
big to realize from a perspective that it
yeah,
curves.
the Pacific Ocean, it's also too big.
Yeah, you'd have to measure the whole thing, but once again, nobody has,
don't
so we
need
don't
that.
have an answer.
That's a liquid, man. I don't need to measure it. Liquid will not curve.
Do you know what a
And because
meniscus is?
Oh Jesus, I'm
This
out.
guy's not getting it. Hold on. If you actually believe in the globe model, you have to believe that at some point water has to curve over the supposed surface of the ball. Right?
Hey, Clownify, before you leave,
doesn't make any
where it
logical
would
sense.
do it.
That doesn't make any
Water
sense.
Where
curves all
you
the
can
time.
measure it without
Liquids in
question.
general
You
curve.
can measure it.
Hey, Clownfly, someone new joined before you leave. Remember, you were planning into studying and working for the rest of your life. So one day you're gonna use all of that money and put yourself in a rocket and explode. Now you can save that and maybe put yourself to do something better for you and your future.
No, it's my life. I can do what I want to do. Also, I'm not planning on working.
Just think about it. Just don't do that, bro. Just come back later.
Wait.
Don't put yourself in a rocket.
Oh yeah, I forgot. You measured the entire Earth. It's flat. Oh wait, you didn't do that.
So you said you were leaving.
You
Now. There's
measured it.
someone
It's a
new.
ball.
Is
Oh wait,
you
you
guys
didn't
any
do that
questions?
No,
either.
I haven't measured it either. I mean, I guess it could be flat, but I don't know why you guys assume if you haven't measured it.
Go
Cool
ahead,
beans.
humanity.
We measure
You
it at
ask a
different
question.
points.
Humanity, you got the mic now.
Oh, I was just saying that liquids curve all the time, right? On the small scale, you got meniscuses. On larger scales, we can see if you, for example, pour liquid oxygen over magnets, basically they will curve around the source of attraction. So on the globe model, right, the Earth is a source of attraction, so they're going to form vaguely a ball around it, which is consistent with what we see.
Like 8 inch per mile squared, you're saying?
What?
8 inch per mile squared. That's curving like that.
No, I'm not saying anything about the size of it, right? If we had a ball which attracted the things around it very strongly, say through like magnetic forces, you could get the same kind of things, right? You can look at ferrofluids, for example.
Do we have that? Do we have that in reality?
Yes.
Ferrofluids? Yes.
Yeah, but
we have the curved ocean in reality. You're saying,
right? Yeah, is water ferrofluid?
I think you'd really struggle to explain the way that you see things out over the ocean without some kind of curvature, or you need some very straight optics, which basically amount to curvature.
And where is the amount of the curvature? Where should to be?
I don't know what that means.
Unequivocally, curvature happens over the ocean.
How I can calculate? How I can measure curvature?
I don't know.
You don't know, but you know that it's there.
I mean, I guess like your dad could hold a ruler on the beach. And
you know that it's there, but you don't know
hundreds
how
of miles out. I guess.
You know what?
There's a difference between being able to make a qualitative observation and a quantitative observation. Yes.
Right. Quantitative is spherical trigonometry dictates that a Earth with a radius of 3959 miles has to curve at an average of 8 inches per mile squared. And it would do so over the ocean without question, because that is the one point where it must absolutely curve without question.
Huh? Yeah.
Okay. So now that we've established that, can you show us where that happens? Because we're not seeing it.
Why do things disappear beneath the ocean by
well,
experience?
Why do things disappear on a basketball court?
I just don't believe
They
that,
don't?
though.
What do you mean?
I would like you. Hey, actually, send me a video of that in DMs, please. Send me a video of you doing the basketball thing.
I don't actually have the upgraded version of this crap they want you to subscribe for my video that I have, but I demonstrated on a 5-foot flat, perfectly level countertop that something actually starts to disappear from the bottom up. Now, if we go over to the other politics server, I would be happy to give you that one.
Perfect. Oh.
And I don't even know how do you guys get permissions on this server? Like, is it like a what 6 months after you join, or what's the deal here?
No clue.
I think
So yeah, if you can explain that.
the politics server just gives you permission automatically once you've been here for a while. Texting,
So they
chatting.
claim that things disappear from the bottom up is exclusive to a ball, and yet we can demonstrate it on a perfectly flat level surface. So the argument
Not
there
exclusive
becomes
to a
moot.
ball. It's just far easier to account
That's why
for
you
it.
say that's why it supposedly happens. That's why boats disappear from the bottom up, because it goes over the curve. Yes, we've all heard Bill Nye the Science Guy when we were 8 years old. Cool, got it, understand it. Now, why does it happen on a flat surface?
It doesn't. What do you mean?
It does. Take your camera out, and I want you to go to a basketball court. I want you to set your camera down. I want you to hit record after it's facing the opposite hoop from where you're at. I want you to be under one hoop, face it towards the other hoop, hit record. Turn around. I want you to walk to the other hoop. You will begin to disappear from the bottom up. And then I want you to go back to your camera. I want you to raise it up 1 foot. You will notice that you will now see your feet at underneath of the other hoop. But now if we go to a place where there's, say, 10 basketball hoops all level in a row, you will then begin to disappear again from the bottom up before you reach the 10th basketball court. So it does
sounds like you're
on a
saying this
flat
basketball
surface.
court isn't flat.
No, I can actually do it on my countertop, which I built myself, and I know for certain it is perfectly flat, perfectly level, and yet a can will start to disappear from the bottom up from 5 feet away, my guy. 5 feet.
I don't believe you.
Well, if I had permissions in here, I would happily show you. Unfortunately, I do not. So until we get that resolved, I guess I can't really show you on here, but we can go over to the other politics server. Or hell, you can add me on Facebook and I'll send you the video there. Or here's an idea. Do you have a countertop at home? Like an island?
Not one that I would describe as flat.
Oh, well, darn. I guess you had a shit contractor then.
True.
Okay, well, maybe upgrade. I don't know. I don't know what to tell you.
Not a priority.
Oh, okay. Well, yeah, I can see why, doing actual experimentation or observations might not be a priority for a ball earther, because you don't, it's really easy to deny the truth if you're unwilling to test it, right? And just remain ignorant to it.
I go near the ocean a number of times.
Oh,
I've yet to have any flat
and did you bring your P900 with you?
I don't know what that is.
It's a camera that you could zoom in, or even your cell phone. You can nowadays if you got a decent cell phone. Do you got I got a 6 megapixel camera. I can go out to the ocean too. I can watch the supposed boat go over the supposed horizon, and voila, just whip out the old phone, zoom back in. Oh my God, it's back in view again. How'd that happen if it went over the curb?
Are your eyes bad or something? Because I've never experienced anything like that. And I've
actually, yeah, I am legally blind. My eyes are very bad.
I mean, that explains it.
No, it really don't. Because here's the thing, right? It just so happens that your supposed apparent horizon just so happens to be at basically the exact same distance as the point of convergence. What's that, you might say? Well, it's when you can no longer see a car if you're 6 foot tall, just so happens to be 3 miles away. Dope. All right, now we're getting somewhere, right?
No, I really don't know what you're getting at, or what you mean by point of convergence.
Yeah, I know. You might want to start studying, when you want to talk about optics and why things disappear, then maybe you should study the points a little bit and figure it out instead of just assuming what Bill Nye the Science Guy told you was true.
I'm not assuming anything. You're just not actually contending with what I'm saying.
No, you're assuming that because ball, the boat goes over the horizon. So boat goes over the horizon, starts to disappear from the bottom up. That means there's a ball that it's going over. However,
No,
I actually
that's
explained to you
with a
that you will
ball.
do the same thing on a perfectly flat basketball court.
But that has never happened ever.
But it does.
But it does not.
Again, if I had permissions here, I could show you that. But unfortunately, I don't. But you yourself can take your cell phone.
I've been on basketball courts. They generally aren't flat.
Okay, well, maybe go to one that is. I don't know. I don't know what to tell you. Find a perfectly flat, level surface somewhere. Anywhere with 100 feet will do.
You realize
go to a nice building. Go to a nice building with 100 feet stretch there, where it's nice, perfectly flat and level.
Buildings are not built perfectly flat and level. That's never a priority when people build buildings.
Some are, absolutely. And it really is a priority, actually.
No.
For anybody that's worth their salt as a contractor, you want it to be nice and flat and level. Like my house, for example. I think I got a good, 60 feet? Perfectly flat level basement. And all my floors upstairs, too. Now, why, they have this stuff called floor leveler. It's a lot like concrete, and it's just thinner, though. So it levels itself out when you pour it. You don't even have to do anything to it. You just dump it in, boom, you're good to go. Dope, right?
It's part of the building codes, isn't it? The building codes and standards.
Yeah, it is.
You're
required to have it level so things don't fall apart.
They don't require that anything is perfectly level or perfectly flat. This is not true. There are tolerances allowed.
Okay. Yeah, we'll allow you that, but they have to be level. A skyscraper has to be level.
What?
Yes,
skyscrapers are built to sway with the wind and stuff. They obviously aren't level in the way you're describing. They're dynamic systems.
Great. Okay, what he meant that using measuring tools like level, you get eventually a straight building. This is what you get.
This seems like a conclusion that's if I build a sufficiently long building, by my rights, if I'm building it according to a level, it's going to be curved.
Well, you would think so, but yet we don't observe it as curved. It looks pretty
What do you mean by
flat. Well, if you had
is that really the strength of your argument? Well, I looked at it and it didn't seem that way. What?
100 feet is perfectly level, perfectly flat, right? And yet you're
experienced anything like that.
Curved.
Listen, the only place you're going to find that stuff is what are they called? They're not called radio telescopes. What are they called? Oh, I can't remember. It's the ones that use the mercury mirrors. Those, when they're not spinning, those are pretty fucking close to perfectly flat. Other than that, you're not going to find anything like that.
Right, but you can use a laser, you can use other things too that they have, strings and stuff like that, right? And then you place the level on that. And
Both of you
there's all kinds of things that you can do.
Lasers go pretty straight, if that's what you're saying. I would agree that lasers
they're
go
called
pretty
laser
straight.
level.
You just don't get the final point, which is you use leveling tool to get relative straight line. If it's like a building and a few meters, it's okay. But if you build bigger, you need this straightness, like in LIGO, you will use other devices and stuff to make sure that the line stays straight. But
how you measure curved line?
But on the Earth level,
how you measure the curved
isn't
line?
flat.
How do you measure the curve? You go to the ocean, right? And you would use mathematics, right? So if hold on. And if you actually had like a nice long, perfectly long level that was like 10 miles long, but I don't know that one exists, so there's probably a problem.
No, you have water level precision systems where you connect a pipe between 2 points, and then you can get a flat, a level plane. Can you not use your soundboard? You don't know how to use it and it doesn't help you.
No.
Just relax. That would actually be a good experiment, to be honest. Just take a high tensile strength string, like a steel wire or something, and then just take it out. Can I see? Do you have any?
They had no success with it. It's called force the line. You can look it up, and you can find a few brave enough flat earthers that did measurements. I can send you, of course, but the flat earthers here will tell you it's BS.
That would have to be conclusive. If you pick like some kind of thick enough steel wire that like will withstand the forces over distance, I just feel like that would be like
obviously it cannot work because it suffers heavy mechanical issues with tolerances and stuff. But
that's why you have holes, right?
You would just make sure the string is under as much tension as you can get it, basically over.
Well, you could put
but you need to rebalance
and it's gonna pretty quickly. Basically, if you want something straight, just use a laser.
Yeah, you use a laser, but you can do it with the string too. You get the laser to get the correct height, right? So then you use the, or you could just put the laser on the ground.
You don't think. You don't think in the. Let me finish. You don't think in this case like a flat earther. Flat earther wants something physical. He doesn't trust optics.
Yeah, I know, but we're testing the physical with a laser.
Right, but therefore he wants a big ruler out of his mommy's basement up to the point he measures.
Oh, no, it's definitely my basement, my potato chip.
The problem with a laser is you need to state what exactly you're expecting to see with the laser and how that contradicts the globe model. If you had a tightened piece of wire and you just took it out like 5 kilometers and it's like not touching the water, then you've got it in the bag. There's no alternative explanation like with the physics of a laser.
Oh, can we talk about like, the physics of water?
Local aberrations and stuff. There's still tons of things like that.
We don't even need to do any of this because water doesn't even behave like this to begin with, Cosmos.
On a calm day, you're not going to get a sweat, and it would contradict flat Earth claims of like water bending.
Water should bend, though, right? According to the globe Earth
contradicts flat Earth claims.
No, it would contradict flat Earth claims of water bending.
Flat Earth has no claims.
Yeah, we don't claim that water bends, bro. Flat Earth just think it's flat.
Maybe we will agree that
water not bending.
Real
water
flat
has
earther
not been.
doesn't make any claims. He doesn't know what the sun is. He doesn't know what the moon is. He doesn't know what water is. He doesn't know how gases behave.
What
Right.
sun is? Can you tell us what sun is?
Like Sasha here. He will not say anything about the sun or the sun
Listen,
movement
Baguette boy.
around.
Yeah,
It's not like
Sasha
you
will.
know what they
Can you
are.
demonstrate the sun and how it happens in your model on Earth?
Yes,
Oh, wait,
Sasha.
no, you can't, because there's never been a star produced in a vacuum on Earth. You're welcome.
Could you keep the assumptions about
That's a
this?
silly way to make anything work. Why would you need to create a sun here to know about how suns work? That's silly.
Well, I would
That's
say
science.
for the
That's
purpose of
That's
induction.
that's not how science works.
For the
is how
purpose of
science works.
No.
But hold on, humanity. For the purpose of induction, we could keep our claims as simple as possible and say the sun is just this thing that emits light, and then base your experimentation off that, because that's indisputable. You're just saying the sun is this thing that moves around and emits light.
You guys are going farther than that, saying what it is, what it's made of, where it is, the distance, etc. You're going way farther than just that. But it is
Your mic is not.
AJ, Mr.
Your mic is not coming in.
And muffled.
Yeah.
But if you keep your assumptions purely to observation, you just say the sun is this thing that moves in the sky that emits heat and light.
Yeah. So what? So what?
But if we acknowledge those premises, the sun is this thing in the sky that moves and emits heat and light, we can do an experiment.
Yeah. What kind of experiment?
But this is already you're already in the realm of theory when you describe it moving.
But no,
dude, no.
The sun moving.
You're not in the realm of theory. You're just making an observation. Humanity, relax.
Right.
No. Because you're not observing its movement at all.
You are.
Yes, you are, dude. It moves from east to west. Come on, bro.
No. It appears to move. That's not the same as you observing it moving.
We observe it moving.
Said it's the same thing.
Then what does it mean to observe it to move?
Even saying that the sun is an object is theory. No, you can't assume that. The sun, the sun might simply be the image alone.
So what?
Do you know what relativity is? It's the basis for all of modern day science.
Yeah,
when it comes to the solar system, right? And he said that there's no difference between the Earth.
We're just talking about observations. That's all we're doing. We're not doing anything more than that. What are you doing?
Okay, then you got to retreat to only talking about observations.
We're not retreating. We start there. That's the base axiom. You start there.
Sure. So what have you observed?
We observe the sun moving across the sky. You do not observe that?
So you do not know. No one has ever observed that without invoking ideas of theory.
Yeah, okay, so what do you observe?
Basically just light.
Yeah, you see light. What is the light doing?
Changing in my perspective.
Now, how does it do that?
What do you mean by that?
Well, it has to move in order for it to change perspective, yeah?
That is not necessarily true. If you want to assert something like that, you need to bring in some ideas of theory.
So, yeah. So when you're still, you're not moving, you're just looking at the sun, you can observe the sun moving across the sky when you're not moving.
No. You're again invoking ideas of theory here.
You're not going to reduce observations. You're not going to reduce observations to absurdity. You're not going to do that. Everybody starts with observations. If you throw that into question, then none of your worldview makes any sense. If you can't make basic observations, then all of your worldview is thrown into question. Everything. What you think is actual reality is not reality anymore. Once you do that. So you're going to hinder the fact that we make observations based on this kind of philosophical interpretation. Yeah, we're not doing that. We're just talking about our observations that we see something doing something when we're not moving. We can see the sun move across the sky. That's just an observation. When you take it anywhere else other than that, you're going to make that into an absurdity. You cannot make any other observation other than that.
When you say we see the sun moving, you understand that all of humanity sees the sun moving.
Yes.
At the same time,
Yeah, bro.
therefore, you collect those points of measurement to understand what is happening.
So when we see the sun moving and we make this observation, everybody collectively can say the sun is moving across the sky.
So,
Yeah,
AV,
so
you
if I
said
take-
the sun. How do you know it's one object?
Dude, you
didn't say
are
that.
you are trying to get into this argument of absurdity where we can't even know what we're looking at.
No.
Yeah.
No.
Yeah,
That's not what I'm
you're
saying.
listen, if you're not going to argue about observations being what they are, and you're going to go into this absurd worldview where you can't even know things are moving across the sky, then maybe you're not even equipped to even have a conversation of logic. Because we're using logic here.
Not following what I'm saying.
Yeah, you're
what
not
I'm saying,
using logic.
I am using logic. You're the ones who are jumping to conclusions that aren't justified.
We're not jumping.
We're not jumping to conclusions. We see the sun move across the sky.
We're seeing
sunrise,
one thing happening.
So
sunrise.
when you say you see the sun, that right there requires you to say it's not many objects, it's one object. That's theory.
It's not a theory. That's not a theory at all. The sun moves across the sky. We see that. You call it sunrise and you call it sunset. Rise is a movement. Setting is a movement going down. Come on. You're arguing. Mute the guy, man. Just mute the guy. This is stupid.
I want to see if there's a consensus behind him. Do you other Globers that are in here agree with his point that we do not observe the sun moving?
Have you guys ever heard of the diffraction limit?
No, I need you here. You guys, are you backing him up? Because you stayed silent when he was saying this nonsense. Are you agreeing with him?
Oh, I agree. How do you know it's one object and not two?
How do you know you're talking, mate? How do you know you're talking?
So your mom is flat. Once again, you can go into another room with that guy and talk about how you can't know anything to be true. Go with him somewhere else.
I didn't.
Yeah, send them on their way.
Anybody else that wants to agree that our observations are not happening the way we make our observations? I need to know this.
So what he's saying?
Cosmos, are you saying the same thing he is? I need you to admit it. Are you saying when you observe something happening, that's not happening? Are you confirming what he's saying?
No.
Okay, so anybody else? How about M.Agent? Are you agreeing?
Why was I muted?
Yeah, are you agreeing? Are you agreeing with humanity that when we make our observation that the sun's moving across the sky, that the sun's not actually moving across the sky? Are you agreeing with him?
He didn't say that.
What did he say?
You're literally strawmanning what he said.
He say?
It is not relevant.
What did he say?
It is not relevant because you just mute what you don't want to hear.
Bang him with the others. Bang him with the others. He's not answering. Bang him with the others. Not saying anything there. Bang him with the others.
Jim,
I can explain the context of what he.
We don't need people to explain the incoherent babbling of somebody saying they can't observe something happening as it's observed. We don't want to hear a reason for that. We already know they're illogical, so we don't need to go into it. Yeah?
Yeah, you're going to explain yourself into that other room, what you're going to do. Carry on, yeah?
You have to have a logic, is what he's saying. You have to have a set of metaphysical constraints.
We already know that. We operate with logic. Don't tell us what we adhere to. We have the fucking standards, yeah? What that idiot was doing was being fucking ridiculous. Now, if you're with him, you're fucking rude.
That's right, yeah. And if you want to join him, just keep saying that our observations are not our observations. Yeah?
Yeah.
Right, so we were agreeing on premises.
Are you the Borg? Are you think for yourself?
I asked you if you agree.
What, that you're looking at something on the sky? That I'm gonna say that it's not. Dude, what are you talking about?
Right. We agreed. We can just say the sun is this object that moves and emits heat and light.
Yeah. Here's the thing, though. I say that the sun's moving across the sky. Whatever you think the sun is, I don't have any control of that. I don't know if you think it's an orange. I don't know. But all I can tell you is that the sun moves across the sky, right? And what we know about the sun is that it emits heat yeah, and in light.
Yeah.
Okay.
Yeah.
These are just the obvious truths. Now we can't get away from that. I don't care who you are.
Yeah, I agree. So if we grant that, could we do a basic experiment?
Well, like what? What are you trying to do?
Right. So we could do a more refined version of Eratosthenes' experiment because we just use hold on. We just use modus ponens. We just say if the sun is an object that emits heat and light and moves across the sky, we can do a measurement.
What kind of measurement are you doing? Like, what are you trying to measure?
So Eratosthenes' experiment used shadows at different points of latitude.
Yeah, but what are you, like, once again, I'm going to ask you, what are you trying to measure?
Testing the geometry of the Earth based on the angle of the shadows.
Okay, but you can't test something that you don't know is actually what you're trying to test. So in other words, you're going into the test already pre-assuming that it's something. You can't start there. You got to start with, I don't know what what the test result's going to be like. I'm just starting with a blank sheet of paper. I'm going to start with trying to get angle measurements. If you want to do this correctly, angle measurements to the sun, right? You know what an angle is, right? Two straight lines. One of those lines is going to be the baseline. The other line is going to be going straight to the top of the pole or whatever, because you're using shadows, yeah? So one of the lines is going to go to the top of whatever thing you're using to cast a shadow, and the other line is going to be the baseline on the floor. Yeah? Two straight lines. So what are we trying to determine with these two straight lines?
We're determining from the angle of the shadows, right? Whether how far if we say, right, we measure the angle of the shadows, and then our conclusion of the experiment is what can we infer from this? Would it be, and say when we've done this, it's either the sun is pretty close, right, or the Earth is curved?
Yeah, well, you're going to make a conclusion based on the information that you're using, right? So what information can we use that's going to give us the determination? And I'll tell you like this. I'm using two straight lines to make an angle, right? So number one, we have a baseline for one of the lines of the angle. The other one's going to go to the top of the shadow, which it's being cast from the object. So that's two straight lines. So one of the lines I need to have a flat line. That's going to be the baseline, and the other one's going to the top of the thing, the object that's casting the shadow. Now the light that's emitting, we're just going to say is it an unknown distance, because we don't know the distance to the sun, right? Unknown, which is basically Eratosthenes' point too. It's an unknown distance, unlimited or whatever, but we're just using the shadows. So all we can conclude is that the surface that those shadows are being cast on are a horizontal flat baseline, because that's one of the angle lines that we're using, right? One of the lines is actually on the ground. So the other one's going to be angled up to the object. So the only thing I can conclude from doing this test is angle measurements on a horizontal plane. That's it. I don't get the conclusion of a globe or round or curving. I'm not getting that, because I have to use two straight lines.
So you can't do any trig to
trigonometry, bro. Like what I'm saying, in order for you to realize that the baseline is an angle measurement, you're gonna have to use two straight lines, and that makes the angle. Otherwise, you can't have the angle that you're describing. So I'm going to determine that using two straight lines, the base of that one of the lines is going to be on the ground, which is going to be the flat Earth that's required in order for me to have this angle. Now, I'll grant that ground might have some elevation change, but in order to get these angles, I'm going to need the ground to be flat. So on the surface, I'm going to have to use flat ground in order to get two straight lines to have an angle measurement, a proper angle. Yeah. You got to have that angle measurement with the proper baseline being a horizontal plane, dude. You have to.
No, you've just assumed what you're trying to test.
No, you're not assuming. See, you're using the ground, and that ground that the shadow's casting on, because the shadow is casting on the ground. So one of the lines is going to be going up to the object, the other one's going to be the baseline. 2 straight lines.
Right. So we'd use 3. We'd use 3, by the way. Not just 2.
You can add another one, but it's just going to be another straight line.
Right. So do you get how it can measure it? The experiment could tell us, right, whether we either have a very local sun, right, or a curved Earth.
No, linear distance can be known to the sun. That's not the object of our test. The object of our test is to determine whether or not the ground that's being utilized for this test, for the shadows, because the shadows are falling onto the Earth. They're not. The sun is only giving us the light that we need to make these shadows visible. Like for us to see these shadows, we need light. So the light that's being shown has nothing. It's got nothing to do with the distance to the light. It's got everything to do with the angle measurement from the object that we're using to cast the shadow. So we're only utilizing that angle for the shadow that's casting on the ground, which I said you need that baseline to be horizontal. And so the other angle that's going up to the object is going to be at an angle of degrees. And we know that because the sunlight's hitting that object at a specific angle.
Right. Is the light from the sun, especially during midday, like the highest point of the sun, is it traveling in a straight line?
Well, I'm telling you like this. What we measure from the shadows is an angle measurement that needs 2 straight lines. So for all intents and purposes, we can say that the angle measurements are done with 2 straight lines. So whether or not there's distortions that cause, there to be something happening, in the air, what we're using is the angle measurement. So we're using the angle measurement. We're not talking about the sunlight in per se, right? We're just using the shadow for our guide.
So let's take a flat plane, right? That will be right one of our straight lines in this flat plane, right? Yeah. And then you take the angle the angle at which light is coming down and hitting the shadow, right? So that's your other angle. Yeah. You've got your zero datum stick, which is meant to just not cast a shadow, where the sun is directly overhead that location as far as no shadow permit. And then you've got your third stick, south or north, that's giving you another shadow so you can get another angle.
Listen, you can do that, but that's not what Eratosthenes tested. I mean, it was only I don't know, you're adding an extra layer to what Eratosthenes. I mean, you could. I don't give a damn if you add 10 more, right? It's not really
This is just maths, though. This is just maths.
Yeah, can you look into... Sorry to interrupt you. Can you look in the chat? If you look in the chat, I've posted 2 images. One of them is of the Eratosthenes, right? And the other one is an experiment that you can actually do yourself. Another one, there's 2, with the sun, and how we know that the sun is not 93 million miles away. Have a look. Not 93 million miles away. Have a look. Look at that as well. Pay attention to the chat, because lots of information being pushed out there as well. Thanks.
So right, that's fine, Jim. But would you say from that measurement, the sun has to be close if it's on a flat plane?
Well, yeah. So
absolutely,
the determination of the sun's distance, close is just an idea of it's not. There's not a numeric value given to that. So nobody knows the distance to the sun. So saying that it's close. Okay, let me just say it this way: saying that it's close is implying that it's far. But what far and close mean have to be used as a metric, right? Either you know that it's far from, let's say, where I am. Let's say I'm using myself as a metric, right? Where I am to where that thing is over there, that's far. But what is far? Is far like an inch? Is it a mile? What is far to you, right? So in relation to you, what is far and what is close? So that has not been defined within this test.
Okay.
You can't use far and close unless you say that we have a metric like the globe Earth is saying 93 million miles away, and then you're saying no, it's closer than that. That's something that's a standard. You're saying it's not 93 million miles away, it's actually closer. And that right there is a false dichotomy, because the 93 million miles away is not even purported to be something that we know, because linear distance to the sun is not known at all by anybody. These are just like these estimations that people have in their head based on the cosmic distance ladder. Now, if you knew that, you would say, okay, the cosmic distance ladder, the first rung would be the size of the Earth. Well, you can't have the size of the Earth if you don't know how to attain the size. So we got a problem. So the cosmic distance ladder, to give you the information that Venus, using transit in front of the sun, to say that Venus is the same size as Earth, it's Earth-like. We're going to use parallax to determine that because of its size and its transit in front of the sun, we're going to determine that we are X amount of distance away from the sun. I mean, you're moving up the rung of the cosmic distance ladder when you're trying to figure it out, right? But it all started with the pre-assumption of the size of the Earth. So the cosmic distance ladder to put the sun at 93 million miles away is already false on its face, because it's using the pre-assumption of the Earth being a globe. And on top of that, we're making a false dichotomy by saying the sun's 93 million miles away and saying, no, it's closer than that. We can't do that. That's a false dichotomy. So in other words, what we can say is that the sun is in an unknown distance away, or unlimited if you'd like, but there's no way that you can know to say that it's closer.
Yeah. And
on a Mercator projection.
That's how it's represented on a flat map. Because since this thing is curved.
Well, does that look very straight to you?
Well, no, because it's curved.
No.
And you're trying to represent a sphere on a flat map. So you have to adjust your lines to match that.
Yeah, they crossed the equator, which means that they weren't going straight, and then they crossed over again. They were not going in a straight line. They were going all over the place. This is not a representation of what you were claiming they've done. At any rate, they would have been referencing north to try and maintain a somewhat westerly heading, right?
Okay.
Which means they just went in a circle.
Alright, so this says they took off and they kept going west, right?
Not if they crossed the equator. They would have had to go on southwest.
Well, if they were above the equator and they kept going west, then they should.
And then eventually they would have had to go northwest eventually as well. Sorry for interrupting.
So if they were originally above the equator and they just kept going west, then they should have not crossed the equator, right? They should have stayed above it.
My friend, what does this have to do with the ground curving?
He was saying that if you go in a straight line, you end up back where you started.
Right.
I asked for an example of anybody in history doing that, and he's presented this as an example.
So in no way do we have a straight line. Now you could say the heading was west. Okay, fine. So what? What we need is curvature.
Okay.
So where's that at?
Hold on.
Yeah, preferably a direct measurement thereof.
Let me look at the flight path. Let me look it up.
What would the flight path tell you about whether or not the ground is curving?
Okay, if you go in a straight line and you come back to the same spot.
Yeah, which this didn't do.
We did come to the same spot, and this says...
Yeah, they didn't go in a straight line.
But it says they only went west.
Fine.
Yes.
No worries. So where can you show me the plane nosing around a ball? That'd be the thing I'd be most interested in. Do you have any maybe black box data from the plane to show us that the instruments were definitely showing a nose down orientation to compensate for the curvature? In fact, do you have...
go nose down to compensate for the curvature.
Oh, yes, you do.
Oh.
At the speed that they're going and the ground that they're covering, according to the curvature that you're claiming, they would definitely need to nose down. But what you could also just figure it out if you looked at the artificial horizon, the gyroscope. Well, that would do a 180-degree rotation over the course of the flight, or excuse me, 360 degrees, because they would have went around a ball, and that particular artificial horizon would have maintained its rigidity in space and would indicate a 360-degree orientation of the plane around that artificial horizon. Do you have that?
Okay. So, if a plane is leveled off, right, it's traveling horizontally.
Welcome to flat Earth.
Around in a curve.
Welcome to flat Earth, right there. Welcome to flat Earth.
Yeah, that's how it curves around.
No, you can't. No, horizontal. Horizontal's describing a flat Earth, not a globe Earth.
I mean, you don't believe in satellites, so...
What does it have to do with anything? What do satellites have to do with anything, and what are they?
What are they?
Yeah.
They're just man-made objects put into orbit for various purposes.
Okay. So are they falling around a ball in the vacuum of space?
They're undergoing circular motion, but slowly falling down at a slow rate.
Right. So these are claims that you're making. What evidence do you have to support those?
Well, you have a live stream of the space station. Several space
stations,
probably.
I can show you a live stream of Narnia or Middle Earth. Doesn't mean they exist.
That's not a live stream then.
Oh, okay. So what are you looking at then? Because that's not a live. What does a live stream prove? Do you actually think that on the television screen or the internet, your computer screen, because you see something that says live on it, that it is real?
Same goes for anything. If that's your strategy,
I know. Isn't it great? We should be always scrutinizing these claims. We shouldn't actually just be taking everything at face value. I agree.
So, okay, so by your assumption, so
I didn't make an assumption.
Molecules might not exist.
No, I didn't say that. I don't know how you jumped to that conclusion. I also don't know why you're making this my argument.
Or you're saying we have, just because we have like a live feed from the space station, that doesn't mean Earth exists. That's what you. I mean.
No, I didn't say it. No, dude. See, this is the thing. You guys always want to change the words and make it out like I said the Earth doesn't exist. No, what I'm saying is what you're seeing on that TV screen, that curvature, that ball, whatever it is that you're seeing, doesn't mean that is real. Didn't say the Earth wasn't real.
Yeah, my bad. I was supposed to say the Earth wasn't around. My bad.
Mm-hmm.
But still.
Yeah.
So, okay, so you're saying just because there is videos, that doesn't mean they're like facts, let's say.
Of course not. Why would you take something that you saw on TV and say it was real? I mean, just because the news is on after Seinfeld doesn't mean it's still not fiction, right? Like it could still be just fiction.
Okay, so then molecules are fiction, even though we have pictures of them.
No. Why would you jump to that conclusion? By the way, what is a molecule, and has anybody ever seen one? And the answer is no. No one's ever seen a molecule. But we do have a way to describe, quantify chunks of matter, particulates. Right. But no one's ever seen that. So we can describe as much as we can detect. So we call it molecules. Well, what does a molecule look like? We have no idea.
Well, we do.
Okay, can you show me a picture of a molecule that someone used a really good microscope to look at?
Okay. So go look at this link. There is images of it. Images in it.
Okay, this is a real life image, or actually it would need to be a photograph of a molecule.
Yeah, that's what the website says.
This does seem like a deflection away from the responsibility of having to, prove that the Earth is a ball.
Yeah, I don't know why we're talking about this. Yeah.
Oh, I see. Okay. So we have a picture of a molecule. Now what?
What do you mean? Now what? You wanted a picture of a molecule? Because so you say because we have a picture of the Earth doesn't mean it's real. Just because we have a picture of
So, no, that still holds true. That still holds true. You want to know why?
Why?
Because I have a picture of Santa Claus. Now, is Santa Claus real?
Where do you get a picture from?
What do you mean, where did I get the picture from? Is Santa Claus real if I have a picture of him? Yes or no?
Does that matter?
No, but then this thing has been explored by scientists.
Oh, I see. So so it doesn't mean that if I have a picture of it, it's real. Okay. So you agree with me then?
Oh.
Okay, so you think that my picture of Santa Claus is the real Santa Claus, yes? No? Yes? No?
No.
Okay, so it's not the real Santa Claus. Why is that? Because we know Santa Claus doesn't exist. How do we know that? Because it's a story, and there's no evidence for it. Just like the globe. See, the Earth would be curving, and we'd have evidence for that curvature, but we don't have that. What we do have is people saying, I flew around a ball, but they don't actually show us the ball. They show us a map of how they flew around something, and then they called it a ball.
Well, it's impossible to see the ball if... So, we live in a 3D world. We can see in 2D. Okay? So, we can't see the other dimension. Right? We judge sizes based off how far objects are, how close they appear to us. If something appears very close, well, I mean, very massive, it must be very close, right?
What does this have to do with anything?
That's how we perceive in 3D. No, because you're talking about just because
it doesn't matter about what we're seeing. Let's just go ahead and measure it. We'll measure all 3 dimensions and see if there's curvature.
Okay.
Okay, where's that?
Where is what, the curvature?
Yeah, where's the measured curvature?
You have a satellite going around it. comes back to the same spot.
Oh, so we're back to the satellites that nobody has any evidence for.
Yeah, no. The way you think that satellites operate is going to require pre-hand knowledge, right?
Okay.
Pre-existing knowledge of the Earth's dimensions. You can't say that we're measuring the Earth with satellites when satellites would require you to have measured the Earth already before placing the satellite into orbit. That's circular reasoning, right? So how did you get the values in order to be able to put your satellite into orbit?
So how did we measure, say, like the radius?
Right. Radius, circumference, diameter. Yeah. Dimensions. It's sphericity. Yeah, how?
I'll look it up and I'll tell you.
Hi.
Hello, welcome in. We're in an ongoing discussion with Kosta at the moment. He's trying to find measurements of the Earth's radius value. Wow, where is everyone going? I mean, I didn't think we were that boring.
Oh, everyone's AFK. Okay, so take a look at this. They use the curvature to measure the radius. Oh, by the way, I gotta go.
In 240 BC, can you please summarize it for us? Can you describe what they did?
Read the whole thing.
Who and who?
I don't know what they did.
You don't know? So you're just believing this? You haven't evaluated its authenticity?
Oh, I can spend like 2 hours reading it, but I can't be fucked.
Okay, so you just believe this. This is just a belief that you have. The trust. You trust that somebody's done this.
Well, if the mathematics hold, then sure.
How do you know that it works? How do you know that it holds true?
So, like, read this thing now.
Wait, you want me to read something that you haven't read?
Yeah, I'm not reading that shit now. It's too late for this.
Wait, no, that's not how this works, bro. If you have a claim, and you have which you have claimed, right? You have to support it. You have to understand what's being claimed, and you have to be able to detail it and summarize it, at least, and be able to express exactly what was done, how it was done, who did it, etc. All the details. I'm not going to read it for you. You want me to prove your claim for you?
No, I just gave information which you asked for. So have a go exploring it, I guess. That's how.
Yeah, you don't. So you don't even know. This could be a bunch of bullshit for all you know.
Okay, so you're basing everything off. Okay, this might exist, or this might not exist. These are all the points you've been making so far. Okay, we have a picture of this. It may not exist.
No, we know that imagery that's presented to us, which is being presented as in such a manner that it's being claimed that it's an accurate representation of our reality from a certain vantage point. If it's claiming that the Earth's surface is curving, we know it's false. We know it's not trustworthy. because that is not our experience. It's not what we measure, and it's not how we use the surface of the Earth. The Earth's surface is planar in nature.
It's flat, you say?
Right, planar, yeah, horizontal, level.
Right, so what happens when I go to the edge then? Can you explain? I'm actually curious.
I don't know about any edge. I don't know about any edge.
So it's like an infinite plane.
No, nobody said that. Like, we're not claiming to know the shape of the Earth, right? Flat's not a shape. So in this context, we're talking about the description of a surface, specifically large bodies of water over distance not curving, right? So if you have a surface and it's not curved, right, it's like by default flat. And that's the context that we're saying this word in here, right? Flat Earth. Not trying to claim to know the shape of the Earth. Mostly testing what we've been told, right? When it comes to the radius and testing to see if that actually matches up with reality. And we have, a huge accumulation of long distance observations and laser tests and other types of various tests. And we can't find any curvature, right? We can see thousands of % further than you would possibly be able to see on a globe, right? Even accounting for refraction. I mean, I was just listening to a professor just now talk about refraction, and he was saying that it's just a small difference, right? It would be 7% or up to 10%, maximum. He said it's not going to allow you to see huge distances further, right? And completely flatten out the water to a horizon that's like 10 times further away.
Well, that guy just said the fucking Earth was a plane.
Yeah, plane, right? So as we're not claiming to know the shape of a plane, right? So you could have like a table could be a plane. It's like the surface of the table is a plane, right?
Don't know the size of it, basically.
Yeah, we're not claiming, and we're most definitely not claiming that it's like a flat planet floating around in the heliocentric, like the globe Earth version of outer space, or anything like that. We're not making claims about things we can't validate either. It's more of an empirical, evidence-based thing, right? It's like we don't try to have a replacement for every single claim that the globe side makes.
Okay, so
I just took a little clip from what I was just listening to there. So yeah, I mean, this physics professor, he's talking about refraction, right? And he's saying, it's a small difference, right? And if you study atmospheric refraction, I mean, I've looked quite deeply into it, and it is just a small difference. When they're accounting for it in surveying or celestial navigation, it's 7 to 8%. And then under extreme conditions, it can go up a bit higher than that, but it doesn't explain these, vast distances we're seeing further. Because once you start to get like a huge difference in the refractive index due to temperature, right, you start getting crazy miraging effects and things like that. It's super obvious. But, I mean, I can show you observations over like a lake that's 21 miles across, super clear conditions. There's no horizon over the entire 21 miles. And the observer height's just 5 foot, right? So that means the horizon should be 2.7 miles away. And then the shoreline on the other side of the lake should be hidden behind 220 foot approximately of Earth curvature. But it's just completely flat the whole way across, right? Extremely clear observation. So it's an accumulation of these types of things. And there's a lot more to it, but that's definitely one of the better arguments in my personal opinion.
So about the horizon then.
Yeah, the horizon on a globe, right? The horizon would have to be physical, meaning that anything that goes beyond it would have to start to become obstructed behind it. And the distance to it's calculated based on the, the size of the sphere. So if you're 6 foot tall, the horizon should be 3 miles away. And then anything that goes beyond 3 miles would start to slowly become obstructed behind the curvature of the Earth. So that's kind of like what we can easily go out and test, the horizon, trying to validate the geometric horizon. These are certain characteristics that have to be present if the Earth's a globe. If you have a 10-mile lake, there has
in size and shape, and so does the other planets. So I have photo of it, which is verified by NASA. Like NASA was the one who gave this photograph.
Behind the curvature of the Earth. So that's kind of like what we can easily go out and test, the horizon, trying to validate the geometric horizon. These are certain characteristics that have to be present if the Earth's a globe. If you have a 10-mile lake, there has
in size and shape, and so does the other planets. So I have photo of it, which is verified by NASA. Like NASA was the one who gave this photograph. So I can share it with you.
Yeah, put it in the chat. Now, the other thing I want to bring up, because this happens quite a bit in this kind of conversation, a lot of the conversation goes to looking at the sky. And what we're actually talking about in this chat and in the three other channels that we populate here on Discord, we're talking about the surface of Earth. So actually, no, it doesn't really matter what you're talking about in the sky.
What do you mean by surface?
The surface of Earth, where we're standing, what we're standing on.
So, okay. So if a thing is so big and you consider a small part of it, okay, yeah, it's flat. If your point of view, if your AI, the area in that you have to walk, it's small, and the size of the Earth is like very big as compared to that, then okay, yeah, it's flat Earth. But if you say as a whole, Earth is spherical. Got my point?
Yeah, there's no proof of it being spherical because they told us the size. I've said this before. They told us the size of Earth.
I literally showed you the proof. See the side chat?
Hold on, I was talking. So the Earth's radius, they told us it's 3,959 miles. So that means that 3 miles, that's 72 inches, 6 feet of vertical drop. 5 miles is 16.67 feet of drop. 10 miles is 66.67 feet of drop. And 30 miles is 469 feet of vertical drop below my line of sight, with a bulge of water in between me and the observation I'm making. That's what we're talking about. So this is observable and it's testable. You could take binoculars yourself and look out over water at a distance and see things that would be impossible to see on the globe of that size. So a lot of people that claim to think they know that the Earth is a globe, they want to ignore the size that was given. They want to ignore how much drop that means. They want to just detract into something else completely other than the actual dimensions of Earth and what that means on the surface. So I hope you're not trying to
equate to hidden height, and I've never seen any instance where the hidden height doesn't correlate with the predictions based on the size of the globe.
Okay, great. Look in the side chat. At 21 minutes after the hour, I posted an infrared photograph of Mount Kanahu, 255 miles away, zero curvature. So how many flat places does your globe have on it?
Mount Kanahu, how do you spell that?
Yep.
Hold on.
There's no refraction. It's an infrared. So you talk about 98, less than 2% of any refractive index. So basically zero refraction with infrared.
Hello, am I audible?
Yep.
So, did you say something? Like, what's your point of view?
I'm sorry, I didn't quite catch that.
Okay. So, but do you agree that if we comparing something that is very small to something that is very big, then the size, like if the size difference is too big, then you can say, yeah, Earth is flat at that point.
Okay, but I have to stop you again because you're saying basically Earth too biggie. Well, I already described the Earth. That's the size that they've told us. And
what?
There's supposed to be a drop over distance. A geometric horizon of an Earth that size at 1 foot above the water can be no further than 1.225 miles. A 10-mile observation of the horizon at 1 foot above the water would make your Earth 264,000 mile radius. That's a 500,000 mile diameter. That would make the radius of Earth just a 10-mile observation out to where the moon is supposed to be. So I have to ask you, what's your margin of error in the size of the Earth? Because I've got a 30-mile observation that would make your Earth like nearly 3 million mile radius.
Okay, whatever you are saying, can you just post in side chat? Whatever
Yeah, I
post you
posted
have.
it. Yeah, I posted it earlier. So we have at 9 minutes after the hour, I have my observation. I'm sunny on the plane. We have an observation of Catalina Island. There's a photograph that I took 8 feet above the water. And next to it, it says Sunset Beach to Mount Orizaba, Catalina Island, 30.88
Okay. Can I give
miles.
you another proof? Can I give you another proof? Okay.
Sure.
So, when sun rises, okay, then at my place, you can say in India, the time is something, suppose you can say 4 a.m. When we move to, you can say England, at the same time is different, right? And when a person is in US, the time is different. So
the time
how
is
it's
different.
happening?
Yeah. Yeah. The
And
time
if you're
of
saying
day,
no,
the
if you're
time of
saying
day, hold on, let me answer. The time of day is based on the location of the sun, the position of the sun over our heads.
yeah. So if Earth is flat, then at all the location, the day would be same time, isn't?
No, not correct.
Yes.
No,
Yes,
it's not.
correct.
No, it isn't.
Yeah.
Because as
Like
the
show
sun
me.
rises, hold on, as the sun rises in the east, at my location here in California, if I measured that sun with an elevation angle from the horizon, it would be a different angle than when it is at noon. So the time of day is based on the position of the sun over your head. So at noon, my noon is different than your noon. That's based on the
Is
position of
something
the
wrong
sun
with
above our
you?
heads.
Is something wrong with you? I'm saying if the whole Earth is flat, then obviously it's the same time everywhere at the same time.
How could
Position
it
of the
be the
sun?
same time when the sun has a position over? Sun is not 93 million miles away, brother. It's just not. That's
How
why you're
is
saying this.
okay, how the distance of sun is impacting? Why are you telling me the distance between Earth and sun?
You're trying to say that the light is parallel to the Earth's surface. No, it's not.
You are
I think
telling me
he
that.
sees it. I think he sees the sun more. I don't mean to mischaracterize, but a lot of flat Earth models show like the sun being kind of like almost like hovering and like circling over the flat surface, relatively close compared to the heliocentric model, almost like a flashlight pointing down. It's like the sunlight is kind of localized. So as the sun makes that like ring shape over the course of the day, the noonday light, is at a different location, kind of like a flashlight beaming down on the surface. Is that roughly correct?
That's what we know about the sun. I mean, we know that when it's light, like it's daytime in my area, my local area, the sun moves away, then it's nighttime. And when that happens, as the sun moves from east to west, then over that, like eventually when it gets across the Pacific, it's light in Japan and it's dark here. This is obvious. This is how the sun. This is how the sun moves across the sky.
Do you have a pen and paper with you?
I'm sorry, say it again.
Do you have pen and paper with you?
I sure do.
Yeah, so can you show me, like when it's show me the shape of Earth and the moon and the sun, and when it's 4 p.m. at your place? Okay, and show me the Earth in a paper.
Yeah, guess what? We don't claim a shape here. Flat is not a shape.
What do you mean by flat isn't a shape? What do you mean by that?
Flat isn't a shape. Okay, what shape is flat?
What shape is flat? Okay. It can be polygon, most probably.
Yeah, flat isn't a shape. Flat is a surface description.
Dimension.
It's an adjective, not a concrete noun. A shape is a concrete noun. Flat is not. Flat is an adjective. It's a descriptor.
I don't know. Like, you started with science, you ended with English. I don't know what's wrong with you.
I didn't.
I'm giving you a second chance.
I didn't mention.
I'm giving you a second chance.
I haven't even mentioned science.
Prophet, do you see the animation in the chat?
Yeah. So what is this?
Yeah, so it's just like a GIF that is a basic idea, a concept, and nobody's saying that this is exactly what the sun is or exactly how it moves. But this is the basic idea that we know how the sun moves above our heads, as you all witness and experience every day of your life. You see the sun moving across the sky. You don't sense any motion.
You gave.
But Prophet, hold on. Give me a second, Prophet. So I want to tell you. So if Earth was a globe and all things were the way they tell us, like that the sun's light is parallel rays from the sun to the Earth, that would mean the Earth would have 12-hour nights, 12-hour days exactly. This doesn't occur. It never occurs.
That's wrong, because Earth is tilted across its axis. The thing is that Earth is
it
tilted.
doesn't matter if it's tilted on its axis. It would still have 12-hour days, 12-hour nights.
No.
Yeah, because if it's a ball, it would have to be half lit at all times. Yes.
There are so many other effects. Suppose.
Okay. How?
Sometimes the location of Earth and Sun, it increased during some days, and during some days it decreases because of the path of the Earth in which they get rotated around the sun. Based on that,
you have 24 hours. You have 24 hours of nighttime. In northern Alaska and the Arctic, for example.
Yeah, in poles they have. The thing is, he's like saying, in poles they have the same thing.
Sure it does.
Yeah, so you're talking about the sky again. So, like, we've quickly gone down to the sky again, the lights in the sky. We're still talking about the surface of Earth.
But do you determine that? I mean, its relation in space to other things is, I think, obviously relevant.
I want you to walk me through how the lights on your ceiling in your room have anything to do with the floor or the condition of the floor or the size of the floor. Explain that to me. Go ahead.
Okay.
Yeah, I mean, if the shape of the floor were such that it obscures the lights in my room from a certain angle, then of course it would be relevant. Like if I had a curved, floor.
Okay, so
in a large enough room.
Okay, tell me what would happen. You go to the hardware store and you say, I'm putting flooring in my room and I need you to help me measure the ceiling lamp so I know what size the floor is. That's fucking ridiculous.
Wait a sec. I think RealGar. The thing is that he's not understanding that the size of Earth is very big and the point of reference he's referring to is very small. So if we have to
stop saying that the Earth is too big. We already went through that. Why aren't you getting that? They told us how big
why
the
aren't
Earth
you
is.
getting that?
I
You
explained
don't
to
get
you
that. If something is very big,
that size of Earth means is a specific amount of vertical drop over distance on the Earth. We don't show any of this drop over distance, so stop saying it's too big. We know how big it is. We know how much drop there should be. It's
you don't
not
know.
there.
Prove me.
Yeah, it's in the chat.
So speaking of the drop and Orizaba, Mount Orizaba, do you have? There's a website called EarthCurvature.com. Do you have an opinion on that website?
Yeah, it's fine. It says there's 460 feet. It's 469 feet of vertical drop in 30 miles.
When I put in 30.88, it says 635.91 is even more.
Okay.
So like it would seem to lend even more to your argument, right?
Yeah, it sure would.
I'm trying to understand this.
Yeah, I'm 8 feet above the surface of the water, so I'm 8 feet above sea level.
Okay,
so that's why it's probably 469. But yeah, you're right. If you're
the highest point is over 2,000 feet. Let's say 2,000 round down. That's fair. So isn't from that distance? Isn't it just the first like 635 feet approximately that would be obscured by the horizon, and not the majority of the midsection and peak of those mountains?
Yeah, so you're at let's say I'll give you the 600 feet. I think it's a little less than that, but that would be at least a third of that island would be blocked. And where that blocking would start at 8 feet above is 3.5 miles out. But I see the first oil rig that is like 6 miles out. And the last oil rig, which is way out there, is 9.95 miles. And I can still see the lights of that oil rig.
Okay, interesting. So one thing at a time, like the mountainscape itself and that landmass, if I understand you're saying that even if the first 600 or whatever, like the bottom is obscured, that would be like a third of the landmass, but the image clearly shows you're saying that it's less than a third, which is actually obscured at the bottom?
Yeah, there's nothing obscured. I can see the lights. I can see the oil rigs going all the way out to the island. They don't go all the way out to the island, but I can see the oil rigs at the farthest one is 10 miles, 9.95 miles.
Okay.
So I can see that oil rig. So the drop isn't beginning where it should be at 3.5 miles.
I hear that.
Everything beyond 3.5 miles at 8 foot above the sea level should be dropping below my line of sight, so I wouldn't see the lights on the water like I do of those oil rigs that are off in the distance.
I want to focus on the island first, and then get to the oil rigs, just so I understand it one piece at a time. The island landmass towards the right side there, it dips and appears to almost dip to the level of the water at the horizon. It almost looks like two islands broken off at a section there.
Yeah.
It looks like maybe that's one contiguous island and they're not actually two broken separately, but I don't know the geography of that place to see if that's a solid section of the island which is dipping below the apparent horizon.
Yeah, it does dip down there.
Right. And I guess that's, if there were no curvature at all or any effects, you would see the whole island, I guess, or maybe it's just that shallow section is just close enough that it doesn't refute the photograph. But I guess my eye was drawn to that, and I don't know anybody else's opinion about it. I guess each of these oil rigs also, the precise distance between them and the viewpoint.
Yeah, I have that information as well.
I guess on the face, without.
And I'll grant you, it's not a very clear photograph. Like, it could definitely be clearer. It's done with a cell phone, so, and not a very good cell phone. So it's a cheap camera. Now, if I had a P900 or something like that, which I don't, and I plan on going to that same location and with a better camera and trying to get a day where I have the clearest visibility, because you see the haze that's along the shoreline of the island. You know, it's quite hazy down there, right? But if you look closely, if you blow that picture up, you can clearly see lights either right on the shoreline or very close to the shoreline. That's absolutely impossible on this supposed globe. Virtually impossible, let alone the oil rigs that I can see lights on 10 miles out before you get to Catalina Channel. The oil rigs go out there until it gets too deep. So they basically go out about 10 miles. And then, like, I can actually see lights on the shoreline, or like I said, right near the shoreline.
If they're 10 miles away, then the drop would be about like 60. It says here on this website, Earth curvature, like 66.69 feet, approximately there.
Yeah.
So are those lights less than that height above the surface of the water?
The oil rigs are approximately 80 feet tall.
Like at their highest point, at that antenna, like tower point or whatever?
Well, you wouldn't be able to see the tower. You wouldn't be able to see those towers at 10 feet, at 10 miles, unless you had a very good camera and could zoom in all the way to that distance. Like the Black Swan, for instance.
Like the deck of the oil rigs is approximately 80 feet above the water surface?
Yeah, the top deck. I mean, they have slightly different heights.
Because if it's 10 miles away and the deck is like 80 feet, I guess you would still see it, but I guess that closest rig, you can see a lot of its deck beneath, like, you can see a lot of the rig beneath those lights, and that looks like it would be more than, you know. I guess I question the distance of this oil rig, if it's actually 10 feet. And I don't mean to, again, sound like I'm just trying to like, not be stubborn or anything, but...
no, it's okay. I can give you some of those. 1 second. I'm scrolling through my DMs. Let me find that. 1 second.
Oh, good. I appreciate it. Yeah. Also, like, I wonder, like, I'm looking at the GIF that John Luna posted, and I'm wondering if like those rigs, that the deck of that rig is like on stilts, kind of, you know, and so you can kind of see, you can kind of see the horizon a bit behind it. Like, it looks like in that animation, I don't know, like the base of the deck on top, where the stilts meet the base of the deck, happens to be like very close to the line of the horizon. And I wonder if that, because he has this green line illustrating lack of curvature is the claim. And I wonder if that's, like, you know, kind of a perspective effect of like the base of that deck on top of the stilts coming close to aligning with the horizon, that makes it, you know.
Yeah, so keep in mind, these are two different locations.
Mm-hmm.
The oil rigs that John Luna has posted, those are off the coast of Santa Barbara. That's oil rig Hill House is the closer one, and Habitat is the further one. Those two oil rigs. The oil rigs I have in mine is in Southern California. Those ones that John Luna posted are more like in Northern California or Central California. So
okay,
they're a couple hundred miles apart from each other.
I see.
So I've posted a couple images, and also I can give you a better idea with a map. 1 second.
miles. Okay. 9.95. I mean, I think of like mirages, you know, like the Fata Morgana and stuff, which can like if a ship is on the distance, they can seem to like compact the size or stretch it out or something. And I understand you said the other measurement like eliminated 98% of atmospheric effects, so you know the images there may look different. Yeah, but just like given the footage of mirages that I've seen, I kind of expect that can have an effect sometimes on like the apparent image, you know, that reaches your camera lens. Oh, I see. Let's see this map. Edith, Ellie, Ellen.
Yeah, Ellen, Ellie, Garfield, Eureka, and I'm standing. Well, if you go to Google Earth, I don't know if you're willing to do that, but right near Huntington Beach, there's Sunset Beach, right where that emblem is, where I've posted it. I'm standing almost exactly on the beach, right where that emblem that says Sunset Beach is. Of course, I'm pretty close to the water. My feet are only a few feet out from the water, so I'm about 8 feet above sea level. So the thing about that 8 feet above sea level is that geometric horizon. If you go to a Earth curve calculator, it says that at 8 feet above sea level, the geometric horizon is supposed to be at 3.5 miles. So let me look up. Let's see, real quick. Let me look at this again. So I'm pretty much looking at oil rig Eva, which I don't have a measurement of that, but I can find it. 1 second.
Expose other things in their, you know, in frame. That's not what this looks like to me. I gotta be honest.
Well, it's similar to like if you're looking southward and the sun is pointing directly at you, so it's in your camera, and you have a building in front of you, and you're trying to capture what's inside the windows of that building. The sunlight will obscure what's in the building.
But yeah, maybe you get like the profile of the building, like the silhouette of it, without any details, and you wouldn't see the windows. Like if you got it just right, you could see the sunlight shining through the windows, you know, but that's unlikely. You'd probably see like a black silhouette of the building. And maybe even that would be like a dim kind of vague silhouette because the sun is so bright behind it, you know, might just look like a needle point or something. But this really looks different. I mean, I honestly, I don't see that as the effect here because I'm looking at the water, and the top of the water's edge, apparent to the viewer, is like slicing through the bottom sections of these structures. And there's a pretty distinct line there of the surface of the water slicing through these buildings. It doesn't look like it's a brightness effect obscuring like or overexposing the base of those buildings.
Yeah, it's also, the law of refractions. What you see clearly is the clearest reflections you're getting off those objects. Anything past that distance starts getting more and more fuzzy.
Wait, is the law of refractions?
Reflections.
Reflections.
Because sunlight reflects off everything.
Right.
And you get different levels of coherent reflections. Some are very incoherent. As you get further and further away, they start getting incoherent. So they're being more scattered. So anything that's more scattered is more difficult to see. Anything that's got a nice coherent reflection, very easy to see. So that's what the actual horizon is. Horizon is where the reflections start disappearing from your view, basically.
Yeah, like I'm trying to understand, like it's not that the base of the buildings are like fuzzier or the resolution or something is getting less, like, you know, there's less resolution or detail because it's not reflecting as well as the surface of the water is. It's that the surface of the water is like cutting a straight line across the base of the building. All of those bases, as they apparently meet the surface of the water, are pretty sharply defined. It's not like they fuzz out or something.
Yeah, that's the angular resolution limit. At a certain point, you'll get past that limit, and they become more visible. Like the camera I'm using has got a very small sensor, so it doesn't provide high quality images.
I don't understand why you wouldn't see the shoreline and the bottoms of those buildings just in a fuzzier or like less resolved, picture, if that's what you're describing. These look like they're clearly behind the top surface of that water.
I would need a much larger imaging device. I would need like a 14-inch telescope with a good DSLR. Then I would get more details, and then you would see more and more of the lower parts of the building. But most people don't take, $10,000, $20,000 worth of sensitive camera gear to the beach to take photographs of landscapes.
I just understand
they don't want to risk the damage.
Good, I couldn't expect that from you. I mean, with how like trendy this debate has become. I feel like somebody could do, but I'm not trying to be like too argumentative here. It's just like the claim is that if you could zoom in further, then you would see the shoreline and like the bottoms of those buildings.
Yeah, every single piece of optical equipment has a physical limit on how far it can see. So I can improve it with a telescope, because the Celestron 1400 HT has a focal length equivalent of about 3,900 millimeters, which is pretty damn good, but it's still not perfect enough. So you'll see more details, clearer details, but you won't see everything still, because everything requires perfect conditions, and perfect conditions never exist.
Yeah, I hear what you're saying. In all conviction, it does not look like to me that that's an issue of like the resolution of the zoom capacity or something.
Yeah, because my best photographs I've ever taken of Toronto have been at nighttime when there's no sunlight reflecting off the water. Because as soon as it gets sunlight reflecting off the water, I see less and less of the city.
Do you have any of those nighttime photographs?
Yeah, just give me a second here to locate some.
Appreciate it. Right, yeah.
The angle changes, and when the angle changes, then it doesn't have this issue. For stuff like penicillin there, that's, like I said, there's multiple different people who can test that product and see what's going on with it. But like I said, some of these stuff is like the James Webb Telescope. Oh, look at this image the James Webb Telescope has. Well, nobody can duplicate that.
Well, I mean, like maybe other countries, like infrared satellite arrays or something like that, can produce their own image of the same object and show a lot of consistency. A counter argument might go. Like even a competing scientific institution, that might have a lot of status at stake if they falsify the images that came from the James Webb Telescope. So that's not something the average person can do in their backyard with their average finances. But there is like a plurality of different research institutions, right?
Yeah, exactly. So I could hire a firm in a different country to duplicate that stuff, and they would do it. But like I said, for some of the stuff just cannot be duplicated by anybody. And that's usually where I put my greatest amount of skepticism in.